anywhere, we will have a Coulomb field, and the higher order fields can be neglected. In that case, the Coulomb field will be dominant, right? That's one example. One example is just a charge E sitting somewhere, you will know there will be a field around. Now you can perform a simple experiment, bring a compass and check it, and you will see that there is a field, right? And we also have a simple Coulomb's formula that tells us there is a field, right? Okay, that is one example. The second example is a circular wire in which a current is flowing, and we know that when there is a circular wire with a current flowing inside, there is a dipole moment. So, that is again another very simple example. So, we also see that there is a role of symmetry also in this case, and now we can relate these simple concepts to a nucleus. Okay. So, normally, like when you devise experiments and so on, it is always better, even for theories, we always start with a very simple model, right. So, we start with the low order multipole moment, we do not go directly to the higher order moments. And we also look at the various factors that will be affecting it, and we try to relate it to the parity of the nuclear states as well. There are many things that go on, right. So, we have already studied the concept of parity, I do not need to go into that again. Okay. So, we know what parity means. So, let us just write the main formulas for this. So, parity of electric moments minus 1 raised to L. L is called the order of the moment. So, for example, just as we discussed before, if L is equal to 0, we call this a monopole. If L is equal to 1, we call it a dipole, and if L is equal to 2, we call it a quadrupole. Now, this is for electric moments. Okay. Now, for magnetic moments, so parity for magnetic moments is minus 1 raised to L plus 1. So, when we compute the expectation value of a moment, we must evaluate an integral, right. The expectation value we must evaluate an integral of the form. So, normally like we studied before, O will be the operator and psi would be the wave function of the system that we are working with. The system in this case can be the nucleus or it can be a nucleon, whatever, and O is the appropriate electromagnetic moment. So, the parity of psi itself does not matter so much because psi appears twice in this equation. Acha, can you make a photo? नहीं ठहरो मिटा दूँ, wait just a moment, I can use that part of the board also, वो वहाँ लिख लूँ फिर आप बना लो. हाँ. So you've taken this, right? ये ले लिया, अलग से भी ये ले लो, अलग से यही वाला part सिर्फ ले लो, so that we can upload this and everybody knows this. Okay. Okay, so the parity of psi itself is not important, because psi appears twice in the integral. So whether psi goes from positive to positive or psi goes from positive to negative, it will not change the integral. Okay.
But there can be some conditions where psi star might just differ from psi. It's a conjugate of psi.
Conjugate, no?
Yeah, that's right. That's right. Psi star might just differ from psi.
Okay. So, if however O has odd parity, O plays a bigger role in this case, right. So, if however O has odd parity, then the integral is an odd function of the coordinates and must vanish identically. So, from this we can conclude that all odd parity static multiple moments must vanish. So, we can say that electric dipole, I will go here. ये क्या हो रहा है आज? So, it means there is no proctor around, right? Okay, so electric examples we can have electric dipole -1 raised to 1 will be equal to -1, which is odd, and magnetic quadrupole -1 raised to L plus 1 is equal to -1 raised to 2 plus 1 is equal to -1, and this is odd. And electric octopole -1 raised to 3 is equal to -1 is equal to odd, because in this case L is equal to 3. So, the monopole electric moment will just be the monopole electric moment is just the nuclear charge Ze, and the next non-vanishing moment is the magnetic dipole moment mu. Okay, and a circular loop like we just discussed, these are some examples, right? A circular loop carrying current let us say I and enclosing an area A has a magnetic moment given by mu is equal to I A. So, these are the simple ones that you have already studied before, right? And we can say that if the current is caused by a charge E, right, if this current is caused by a charge E which is moving with, let us say, with a speed, right,